In this video, we're going to calculate the voltage necessary for the electrolysis of water. Let's begin by just kind of sketching a setup of what this reaction might look like. So we're going to be putting the water in a beaker with a couple of electrodes. And for the electrodes, you can just use anything that is a good conductor. Like platinum is an excellent electrode for this particular reaction. You could also do it with graphite. It works really well. And as we know, we need to connect these electrodes to a battery or some sort of power supply. So I'm just going to use B for battery. And in this beaker, we are going to just fill it up with some water. And one thing that we know about this reaction is that because water is actually not a very good conductor of electricity, the electrolysis is going to work a lot better if we add a little bit of acid. So I'm just going to put H plus as the abbreviation, and actually what we have found is that 0.1 molar acid is ideal concentration for the electrolysis of water. Just again, this is just to increase the conductivity. Now I've done this with other things, not just acids. There's a lot of substances that can work here to increase the conductivity. The overall reaction of the electrolysis is that we have our water, which is in the liquid state, and it is converted to H2 gas and O2 gas. You can actually see these gases bubbling during the electrolysis process. To balance this equation, we need 2 H2O molecules and 2 H2 molecules that are produced over here. The half reactions of this are kind of a little bit difficult to predict. So one of the half reactions is the H plus from the acid that we need to add to increase conductivity. The H plus picking up electrons to produce the H2 gas. Water is also a source of H plus ions as well, so the H plus ions are not only coming from the acid that's being added. Our other half reaction here is the water molecules to H2O being converted into O2 gas, 4 H plus ions, and 4 electrons. The first reaction with the H plus as the reactant, this is an oxidation reaction. Nope, this is a reduction reaction. Reduction is gain of electrons. And so this is taking place at the cathode, red cat. In our second reaction, this is our oxidation reaction because oxidation is loss of electrons. So this is taking place at the anode. For us to calculate the necessary voltage, we're going to use the Ecell equation, where the voltage of the cathode minus the voltage of the anode will give us the necessary voltage. The voltage of the cathode is the H plus, which is 0 volts. And the voltage at the anode, this is water with O2 and H plus. This is 1.23 volts, which gives us an overall Ecell of negative 1.23 volts, which means that this reaction requires, in theory, about 1.23 volts to work.